Okay, let's take another example of the product rule. And here I have the function y equals x squared plus 5x, and that times ln of 2x minus 3. Now once again, we identify this as a product because I have the function x squared plus 5x multiplying the function ln 2x minus 3. So this part here is going to be my u, and this part here is going to be v. And we know that dy over dx for a product is given by u dv over dx plus v du over dx. And until you get used to using the product rule, until you're very familiar with it, I'd say write this down for every question that you do, and that way you won't have to refer to the formula book every time you do this. So dy over dx, I have the first function times the derivative of the second. So u is equal to x squared plus 5x. I got times the derivative of this function. So the derivative of ln of something is always 1 over the function. So I have 1 over 2x minus 3, but I got to multiply it by the derivative of what's inside, and that just comes from the chain rule. So that's times 2. So that's u dv over dx. Then I've got plus v du over dx. So I have ln of 2x minus 3 times the derivative of this part, derivative of u, and that would give just 2x plus 5. And I can simplify this a little bit, and I could rewrite this as 2 times x squared plus 5x over 2x minus 3 plus 2x plus 5 times ln of 2x minus 3. When we consider product rule, we've always had only two functions multiplied together. So here it's always been u times v, a product of two functions. But what if you have a product of three functions? So let's say we have y equals something like, let's say, e to the power x times ln of x times the sine of x. So I have ln of x, e to the power x times sine of x. Now this really is three different functions here being multiplied together. And how do you find dy over dx? And there's more than one way of doing it. You can actually call this u, v, and w, and then derive a dy over dx for that. But what we'll do is, let's say, take this entire thing, the e to the power x ln x as your u term, and let's take this sine x term as my v term. We know that dy over dx is given by u dv over dx plus v du over dx. So my first term is going to be e to the power x. It's going to be e to the power x times ln of x. So that's my u times the derivative of the second function, or derivative of v, which is equal to cos x. Then I've got plus the v term, which is sine x. So I got sine x times the derivative, so I got times, I'll write it over here, times the derivative of u, so that's v du over dx. But now u itself is a product on its own, so now I have a product of e to the power x and ln x, so I got to use the product rule for that as well. So using the product rule on that part, I get e to the power x, so the first function, times the derivative of the second, so that's 1 over x, plus v du over dx, so that's the second function times the derivative of the first, so that would be e to the power x ln x. And just to run through that again, what I've done is I've taken e to the power x ln x as u, sine x as v. So the first part of the product rule, we have u dv over dx, so that says u, which is e to the power x ln x, that's my u term, times the derivative of sine x, which is cos x. Then I got plus the v term, that is the sine x term, times the derivative of e to the power x ln x. And the derivative of e to the power ln x, I've used the product rule here again, and this is du over dx, if you can think of it that way. And if I want, I could simplify this a little bit and say that dy over dx would be equal to e to the power x ln x times cos x. Then I've got plus e to the power x times sine x over x, so that is the sine x times this part. Then I've got sine x times this part as well, so I have plus e to the power x ln x times sine of x. So this would be the derivative of the three products here.